Hello. So today's problem is most profit assigned work. Most profit assigning work. It's a Leetcode question. Let me quickly read it again. So this example we have difficulty, profit and worker. So we have like 4 workers with the skills 4, 5, 6, 7, and we have different jobs, like 5 jobs, and we have jobs ranging from 2 to 10 and different profits, and we need to maximize here the output, so the profit, aggregate profit, total profit, and every worker can do the kind of maximum 1 job. Yeah, what I'm looking for, because the worker can do maximum 1 job, I would love to among all the jobs that worker can do, that have difficulty less or equal worker skill, I wanna do the ones that I wanna select the ones that has the most profit. So in this case, for the worker 4 with skill 4, we have jobs the max job here is so we have job 2 and 4 that are qualified. Job 2 is profit 10, job with difficulty 4 has a profit 20. It's obvious we have to take 20. With skill 5, the same set of jobs is available, so it can 20. With skill set, the skill level 6, we can have let me copy this. So we have worker 1, so it can do job 2 profit 10 and job with skill level 4 and profit 20. So it says so we select 20. For worker 2, let's say worker 0, worker 1, it has skill level 5, so it can do the same 2 and 4. Job 2 profit 10, job 4 profit 20. Select the maximum, so it's 20 for worker 2. So it's skill level 6. So we get, now we can actually do 3 kind of jobs. Job 2, job 4, and job 6, and here profit 10, 20, and 30. We select 30. Worker 4, worker 3. It can do like skill level 7, so it can do up to again 3 jobs. First 3 jobs. So job 2, job 4, job 6, and it's profit like 10, 20, or 30. So we select 30, and if we aggregate here like 60, here it's 40, and the result is 100. So the output is 100. So for every worker, it seems we need to do the following. We need to, among all the jobs it has, all the difficulties he has, all the jobs that qualify, we need to select the one that maximizes the profit. Yeah. So it's kind of twofold target. So we need like have a set of jobs with difficulty less than worker difficulty, less than or equal, and we need to maximize the profit. Profit should be maximum, and we need to do that. What are the constraints here? So the constraint is that the number of n is the number of probable jobs and difficult, yeah, and m is number of workers, so it's like 10 to the power of 4, and the actual value is from 1 to 10 to the power of 5. So if the first idea that I have in my mind is actually, so n it's like n is like n number jobs equal n, and then it's also equal to n to the power of 4, and number of workers is equal m yeah, and it's also 10 to the power of 4. 10 to the power of 4. So the first idea I have in my mind is we have for every worker we ask from the workers we do n minus 1. We do the following. We need to find what the set of jobs it can do, and based on what the set of jobs it can do, we can get the profit. So if we just go one by one jobs, so we have number of workers, actually m, and jobs like n. So in the worst case, we're gonna go iteratively one by one, like job 1, job 0, job 1, job 2, so on and so forth. job n, and then there's gonna be a cutoff point where we can no longer, like, let's say he can do the job k, because job k is the skill to the difficulty of the job k is jk is less than or equal worker s skill level, but jk plus 1, so here I order that jk plus 1 is like greater than the skill of worker s. And we can do the following. So we probably, like, initially we can do the like linear, so it's gonna be O of n, and then by doing this linear we can also save the maximum maximum profit so far, and yeah, we can basically record it. So the complexity of this algorithm, so to reiterate, the first idea that I have is to linearly go one by one for every worker. We're gonna go to the jobs that are gonna be sorted, and we're gonna find the cutoff point when no longer can execute the job, and we're gonna have a global maximum of the profit, and we're gonna record the profit for this worker, the maximum profit it can do. So we have like m workers, we have n jobs, so the complexity of this algorithm is gonna be of m by n, and it's equal and we need first to also to sort the jobs. Yeah, so sorting the jobs is gonna be n log n, plus we need to go one by one for every worker. You need to go one by one, so it's gonna be O, so it's going to be O of n log n plus O of m by n, and this one actually, like, because m and n have the same order of magnitude, so it should be like O of m by n, and it means that O of n to the 10 to the power of 8, and actually this one is already like close to what the computer can do within seconds. So usually a computer can do 10 to the power of 7, 10 to the power of 8, and yeah, it seems like we can exhaust the cycles, and it will be a time out of limit exception. So the idea that I have right now to improve this part, instead of going one by one for the jobs, we can basically do the following. We can first save the maximum profit so far for the job, for the jobs, and then we can like do the binary search for this cutoff point where the so like worker, let's say 0 means worker can do the job, and 1 means worker cannot do the job, and there will be like index I, where for the job where the current worker cannot like do it anymore, and then we can have like the global maximum for the profit for the jobs up to the point I, and we can find this cutoff point doing binary search, and then I can get the maximum profit from the array we already pre-calculated for the job I, for the all the jobs that were before I, with the skill, with the difficulty before and or equal job I. Yeah, so this, so in this case, we were gonna arrange our job difficulty and the profit. So here gonna be the profit we can achieve with the maximum profit we can achieve profit array. Maximum for the job I, it's gonna be the difficulty of it. We're gonna sort it 2, 4, 6, 8, 10, and the index 0, 1, 2, 3, 4. And for the MP, it's going to be maximum profit. We can get with jobs that are with the jobs that are on the difficult level the same of job Y or less. So here the maximum profit will be 10. The maximum profit will be for the jobs that are difficult, that the difficulty is less than or equal 4, gonna be 20, and then gonna be 30, and then gonna be 40, and gonna be 50. And we'll have for workers 4, 5, 6, 7. For every worker, I'm gonna, let's say worker 4 with the skill set 4, I'm gonna do the binary search. Again, I can also optimize here, and instead of doing binary search from the start of the array, I can order the workers by their skill level, and then every time I find the job that the current skill level can do, I can move the pointer and start next binary search from there, from that pointer as a left side, as the left bound. So here for the worker 4, we're gonna binary search level 4 between the jobs. We're gonna find this cutoff point 4. I'm gonna get the profit 20. For the 5, we do the same binary search for their jobs with a skill set more than less than or equal 5. We're gonna go again 20. And then we're gonna do for the 6 and 7, so on and so forth. I'm gonna be 20, 20, and then gonna be for the 6, I'm gonna be here 30, 30, and 30, and gonna be 100. So the complexity of this is all improved. So the first method was complexity was first method. First, it was O of n log n plus O of m by n, and the second one is going to be O of n log n plus O of, so we'll have for every worker, so m multiplied by, we're gonna do the binary search for the job, for the cutoff job it can execute, it's going to be log n, and this one will be 10, like a sort of 10 to the power of 5 multiplied by 4, 10 to the power of 4 multiplied by log 10 to the power of 4. So it's like, if we move this, it's going to be 4 by 10 to the power of 4 by log 210. So it's going to be just constant by 10 to the power of 4, around that one. Yeah, it's so much better. The only question I have right now for this one is this job level can have like duplicates, and ideally we wanna, like, for the duplicates, if you're gonna, we need to, for the duplicates, we need to just have a little bit more careful when we gonna sort this array. I wanna sort it like first by skill set, and then I wanna sort it by their profitability, like profit, so that their skill set so increasing and the profit also should be increasing. So whenever we have this move to the left, and we have, like, let's say we have like jobs with like skill difficulty 4, like 4, and we'll have like maybe 3 again in the beginning, and we have difficulty in this case, let's say 3, 1, 5, and maybe 6. So the max profit in this case is gonna be like 3, 5, 6, and then let's say have a job with skill set with the it's like profit here, it's profit, and this like job 5 with difficulty 5, and let's say it has like profit 2, and then max profit in this case going to be like 6. Yeah, because in this case, even though we will find this cutoff point, we will not we we try not to execute this job, because the profit it gets is less than previous one. So we, in this case, will just save 6, meaning that for every worker that has like skill set 5, we'll just execute their this job, because it brings the most profit. Yeah. So and this is for the same skill set, and also, yeah, we can also do the restart the binary search for the we can sort workers. It's going to be of m log m sort workers, and every time we do the binary search, every time we do the workers, jump to the next worker, we can like reduce the left bound for the binary search. So for the left bound initial going to be -1, and then it's going to be whatever we found for the cutoff point index, we're gonna subtract 1, and it's gonna be the left bound every time. And that meaning that if we pass this like 5 worker, like yeah, worker 5, the cutoff point will be like, for this one it will be like this this job, yeah, this job, let's say we have like worker with a skill set like 7, we'll still find, we'll look in the end of this array for binary search, reducing like range of the binary search on every new worker. So it will bring us even like better. So it's going to be in the third method. It's going to be of log n log n plus of m log m plus we're gonna reduce the so initially we're gonna search in the range like for the every worker, so it's gonna be O of m. We cannot escape this iterating for the worker, for the every worker, but the range so it's gonna be multiplied by the, let's say now it's like log of n upper bound, but the issue is that on the first stage we're gonna have like binary search among n candidates. The second worker we're gonna have like let's say we found the cutoff point here like index I1. The second one, so it's going to be from 0 to n minus 1, and the second binary search is going to be from I1 to n minus 1, and the third one binary search is going to be from result here I2, from the I2 to n minus 1, and so on and so forth. So we're gonna every time we're gonna reduce this I3, and then fourth what's going to be I3 I2 I3 here, then I3 on n minus 1, and we here we'll have so we'll have log n, and then maybe log n minus I1, and here log n minus I2 complexity, and here like log n minus I3. So this one will be converted, instead of multiplying, it's going to be sum I1 from 1 to m, and then here going to be a log n minus I, like let's say k from 1 to m, I k. So this term will be converted to this one, and it's like lower than the just doing multiplication. I guess it's even like significantly lower because we kind of do this by I wonder if like this term can be like log something like log m by log n, something like this. Okay, so let's start coding for this exercise. We already out of time probably. Yeah, I've been like explaining for 30 minutes as now. Let me just start coding. So you can see that I don't have any submissions there. Let's have Excalibur, not Excalibur, but Reach codes, if it's available today. Yeah, it's available. I go to the Java, let's say, and let's say we have okay, let's start a new internet is, I don't know why, terrible today. Create max profit, let's say we have max profit, what's that, 8 to 6, say 8 to 6 here, 8 to 6, no, 8 to 6, 8. Okay, so the language gonna be the Java, Java, and we have the test case solutions. Where is the code? Okay, code is here. So I have the API like this. Have this say not low, then let's say we have a profit, so we have arrays sort difficulty. Okay, so we wanna sort the difficulty and so I didn't want to save it into a separate array, but since we have to do that, so for into I equal 0, I minus 11, let's say we have int n equals difficulty length, and we have int two-dimensional array for our like jobs, and then we have 2, and for every I with less than n, I plus plus, we're gonna just copy here the jobs I was new, and then here difficulty I, and then profit profit I, and then I wanna also, yeah, that's probably it, and then arrays sort, I wanna accept jobs, and then I want to have custom job 1, job 2, custom sort function, and it's gonna be compare the difficulty of the job if integer compare, and then we're gonna have job 1 and here job 1 0, job 2 0 0. Then I want to compare their basically I want to compare their profit. Else just return the comparison. So this one, and then to this one, and then to this one, and this. Yep. And then I want to do this for int I equals 0 minus I plus plus. And I want to have, instead of profit, I want to have maximum profit here. So we arranged by difficulty and then profit, the same difficulty, profit increasing and difficulty increasing also. So I want to have like max profit equals job, let's say 1 0 1, and then starting from the first job, like indexing from 0, so job I max profit equals, let's say MP xp, max p equals max and job 0 job I 1, and then MP the same, max p, and then I want to do this update for the jobs I 1 equals max p. Yep, this one is going to be our array, and we're gonna do there for the every worker. So we have int equals worker length for int I equals 0, I minus less than m, I plus plus. Yeah, I want to also do this, as I said, arrays sort worker. So I wanna do this import Java utils arrays, and let's call this solution, and then worker length. And then I want to do sorting here for the worker, and then supplying like just this one worker by the skill set. Yep. And then I want to have like this public private, and it's going to be return the index binary search, and I want to do the jobs binary search jobs, and then I want to find the level for the worker, and I want to also pass the int left bound for the binary search. And then I'm gonna do the following. I'm gonna for the every worker and it's gonna return the left bound. So int left int index equal binary search. So initially int left bound equals -1. So we do left bound left, then we need to do the worker I, and then we need to pass jobs, and then we're gonna max profit. So we gonna save int max int output equals 0, and then we're gonna get the jobs jobs index max output equals equals jobs index. So we're gonna update the output, and we're gonna need to also update the left bound. So left bound in this case is gonna be index -1, and then we're gonna return output. And for the binary search here, I wanna do so we have in left bound and right bound is equal jobs length, and then while right minus left greater than 1, I wanna do this int middle equals r left plus right minus left over 2, and if jobs I wanna have difficulty is greater than work, then the current worker skill level, if it's greater, then it means that we need to move probably. So it's that it means jobs. So like it's here like jobs m. So it means that we need to move the left pointer. No, right pointer. Yeah, right pointer. Else left equals m, and then return l. Yes, in this case, if their index is greater than -1, yeah, if the index is greater than -1, we need to do this operation, and if not, we just do nothing. Means that we didn't find the right it means that all our workers is not that skillful and they cannot do the jobs. Okay, so let's try to do some testing here. So we have public static void test1, and we have based on what we have here, difficulty profit worker. There's just one example. Interesting. Okay, we'll do this. Integer difficulty equals like this. Profit equals this. And then int worker equals this, and then int expected output equals 100, and then solution, so new solution, and then we do solution dot max profit assignment, and then there are going to be difficulty, profit, and worker. And we're gonna have int output equals, and let's say boolean past, no, expected output equals output, and system out print then okay. I have here some, let's say test 1. Let me think about, so here we have jobs, we create them, we sort them, we then update the max profit so far, we sort workers. For every worker we do binary search for the index for its level, so we need also if we're passing level, we are passing left bound for the binary search, and for the right bound it's going to be always job lengths. And then we're gonna increment add the output if the index is greater than -1, and we are gonna update the left bound for the binary search. Here, if the job's difficulty for the one that we tried is greater than the worker level, that means that the threshold is laying into the left part and we need to move the right pointer. Otherwise you need to move the left pointer, and because like we are looking into the cutoff point, it should be less than or equal W, we need to return the L here. Okay, let me run the code. Compile error, where is it? 51. Test 1, okay. Run code. Again, compile error. Solution. Run code. 13. Getting better. I keep forgetting how I can integer compare. Okay, so compare if this one is equal to each other, then I need to do this one, otherwise like this. Sounds good. Still, oh, okay. 9. Run code. Util. Run code. Second type. Job of 13. G1. Integer compare. So this one should be int and this one should be int. So line 19. It seems like it's referencing to the max p. Can find symbol int max p. Max p, max p. For binary operator. Okay, jobs. Jobs index, so index 1. Passed, okay. Let's try this amazing code on our Leetcode platform and check what's gonna be there. Okay, can I execute it? No. Code, submit. Oh no. Failing somewhere here. Support visualization. What can be run here? I wonder what can be run here. So we have output 768. What if I don't play with this fire? What if I don't play with this fire and try to not to update this left bound? Can it be better? Yeah, still. Yep. Okay. Let me copy this one. Case. And I'll try to figure out what's wrong with it. So we have profit and we have workers, and we go one by one. Let's say we have difficulty 5, then next difficulty gonna be 5, and next difficulty gonna should be 17, 5. 517. So here is 26, here is 68, 517, and then the next one after 17 is 21, one should be 99, 21, then goes 24, should be 56. And then goes 30, and should be 55. Running out of space. 30, and then it should be it should be 50, 100, and then it should be 53. So that's our 53, 25, and then it should be 63, 63, 93, then 70, .43, and then 92 and 3. Yeah, so maximum profit so far. Yeah, so it was difficulty. This is profit, maximum profit, MP so far 68, 26. Oh, so like maximum profit here again 68, 68, 99, 99, 99, 100, 100, 100, 100, and 100. If we do the binary search here for the 60, for the worker, like let's say for the worker 96, so it's gonna be 96. It can do basically whatever job, very skillful worker. You don't have even job for it to match his skills, but like worker 96 receives 100 profit. Then we need to go to worker numbers with skill set 3, so it has the lowest skill set. I have profit 0. Worker with skill set 55, I'll have 55, so it's like 55, still 100, so it can do this job. 50, then worker 30, 30 can do 99. If we have worker 11, so it can do 68. I have worker 58. 58 can do again 100. 68. 68 can do again 100. And then we have 36. 36 can do 99. 26. 26 can do 99. And we have 1 can be 0. Cool. Because minimum difficulty you have 5. That worker is has very poor skills. So we have 100, 100, 100, 100, so it's like 400. We have 99 plus 99 plus, so it's gonna be 198, plus 99 and plus 68. So it's gonna be 400 plus 397 plus 68. 397 plus 60 is gonna be something that I am not. So it's much bigger, like, than the expected. The expected output is much. What I counted here is much bigger than the than there. So 19. So it's like plus 100. Yeah, I have here. So like 3. Okay, so it's like here 297. Yeah, 297 plus 68 gonna be 385. Oh, 785. 785. 765. Again, probably poor counting skills. So 98. To 68 plus 68 gonna be, oh yeah, sure, okay, so 7 6, so it's gonna be 5 7. No. 5 6 6 765. Yeah, 765 should be the output. Yeah, it's expected, but I don't know why we have this one 768 as an output. Index greater than -1. Let's check this out. Based on my calculations, it should be the right answer, but I don't know what happened here. So we have difficulty this one. We have profit this one. We have worker this one, and we have output 765 expected. 765, yeah, expected. So let's say test 2. Let's remove this one. Test 2. Let's run it. Cannot do that. Why? Test 2. Okay. Whatever. Failed. Okay, what I wanna do here, I wanna basically what I wanna here. I wanna here to print len there maybe to check the difficulty array if it matches what I made here, like max profit. Yep. Let's print it out and see what it outputs. Then for int I equals system out print on I less than n I plus plus. So I'm gonna go system out print, and then I'm gonna print this bracket, and then we're gonna print jobs I0, and we're gonna go comma plus jobs I1, and then I'm gonna add the bracket to the output here, and then diff width, and diff. Okay, let's run it. So the difficulty here, so it has let's format it somehow. So 568, then we have, I wonder why we have this 21 here. Oh, that's bad. 21 shouldn't be there, so I found the bug. Yo, J2, oh no, like here, J1, no, that's right, integer compare. If the integer compare is equal to 0, we should return integer compare by the second, and otherwise you should return the integer compared by the 0. Okay. So this function was wrong. Let's try it again. Just simple typo. Run. Okay. Code, submit. Let's do this trick. Maybe I can get even better. Not really. Not really better. Let's check what they have, what the best people do there. Oh yeah, I know. This is this is much more efficient code that I have here. So they do. Potentially, I can even improve it here by doing counting sort, and then it's gonna be of n instead of like n log n or m log m. Yeah, I can do the counting sort here, but it seems a little bit overkill here. So they are not even doing binary search. So difficulty, profit, and workers. And they are doing, what they're doing here? They're doing max difficulty so far. And then they're gonna do this save the array max profit. And then they gonna yeah, need to dive in. Seems like, so this one, complexity of n, and yeah, I assume it's some kind of counting sort, because this a of I, it looks like a frequency or something like that. And then there's probably some magic happening here, because of the counting sort, how they can optimize it. Yeah, but this sub-indexing doesn't look obvious for me right now. Let's see what my neighbors do here. So they do sort workers, they do priority queue. Okay, makes sense. So they have priority queue for their difficulty and profit. So it's basically sorting the same, sorting the workers, doing this, and then they do priority queue. So they pull, okay. So instead of doing binary search, they have ever decreasing the priority queue, taking the one that's on the edge there. Yeah, very similar to my solution, but with the priority queues. Yeah, and it's quite shorter. There are less issues that might incur. And do we have editorial sorting? Okay, accepted. Blah blah blah. Complexity. Okay, so it's not even a binary search here. Okay, I'll probably wrap up. Still, I guess I was spending a lot of time on explanation for my approach. Like I spent like 30 minutes for explanation, and then maybe like 20 minutes for writing the code, and then maybe 10 minutes for debugging. So I consider that fail.